closely. We have been going through different questions, and from that supplementary system of questions that I give you, you saw that we started looking at the partial fractions. So I have sent a good number of conversations just focusing on partial fractions. But what I want us to focus on in this conversation is a conversation that is very important, and you all need to pay solid attention to this conversation. And I want us to address question number 25 of your assignment. Question number 25 of the assignment is what I want us to look at. But before we go any further and look at question number 5 of the assignment, I want us to consider the following. Let me just lay the background to this conversation. Confirm you can hear me before I continue again, and you can see the screen. Just a quick confirmation would help. Are you able to see the screen, and can you hear me clearly?
I get you clearly, and I can see the screen on my
side. Okay, that's fine. And thanks for the confirmation. Now, listen carefully. In the business world, and the world of investments, one thing that you are going to learn is that as the business grows, shall have a lot of investment options presented before it, and they would always need to choose most of the times between several options of the investments, right? Investment options. So what now you need at that point is the capacity to analyze and choose the most viable investment option. You want to check and assess which one of the investment options gives you the maximum possible return. That is what you're interested in. And at that point, then you need to know how to conduct what we call investment appraisals. Should be able to appraise the investment. How do you do investment appraisals, and what are they? Listen carefully. Investment appraisals are basically the techniques, the methods that are used to test the viability of an investment option, right? Of an investment option. So those techniques, methods that you use to test the viability of an investment option, we call them the investment appraisals. Is that clear? Yeah, those are investment appraisals. And we have got several of them, and they include the following. Number one, you have the payback period. The payback period, I will speak to the payback period very soon. Yeah, the payback period is one of the methods that looks at comparing what you invest into the investment and what you get, right? The cash flows that you raise from the same investments. Okay, and then so it looks at the time period, right? The period of time it takes between the time you invest the money and when you recover. So how long does it take for you to get back the money that you invested in the project? So that period is what you call the payback period. So if you invested some amount of money here for an investment worth 50,000, pay attention, then the question is, when are we going to get back the 50,000 that we invested? Usually in years. So that period is what you call the payback period. And actually, the shorter period is always desired. I want to speak to the one that we want to look at today, which is the net present value. Now listen carefully. The net present value method, NPV, net present value method of assessing options, investment options, it is given us the initial cash flow, right? The initial cash flow, of course, it bears a negative sign. Then you add the summation of the discounted cash flows. You are not getting this, I'll repeat. You have the summation of the cash flows, the present values of the cash flows, all right? Let me just say summation of the present values of the cash flows, and then you deduct the initial investment, how much you invested in the project. Yeah, I'll repeat. Please, colleagues, how you find the net present value? You basically consolidate the present values of the future cash flows or the expected cash flows, and then you deduct the initial investment or initial outlay. Yeah, the amount that you invested in the project. So now, what is the decision rule? So the decision rule is if you find a positive NPV, then you accept the project, right? You get the project, you pick the project. It is a good project. Why? Because what we get from the project, it's higher than what we invested. All right. The return from the project is higher than the investment or the cost of the project or of the investment. Then the negative NPV is to be rejected, right? Let me just say is to be rejected. Why do you have to reject this? It's because it implies that the returns that you get from this investment is actually less than what you invest in the project. So whatever you're going to get from the project, when you consolidate it, of course, the present values thereof, the total amount will be less than what you injected in the project. And because of that, you do not accept this project. What if you find the net present value 0? What if it is equal to 0? At that point, when the net present, if the net present value, if the net present value is equal to 0, what that means is that you're breaking even. That is to say, what you receive from the project is exactly what you injected in the project. There is no gain whatsoever. You're getting exactly what you pumped into the project. So because of that, usually it's not advisable to invest in such a project. How can you invest in something then where you get exactly what you invested in? Because the whole idea behind investment is that we should gain, right? We have to get some return, some positive return, of course, at the end of the day. But if we are getting exactly what we invested, even after 5 years, then the project is not worthwhile. Okay? Any questions? I've emphasized on the decision rule. Let me get back to the consolidation of the present values. Now, when we're talking about the present values, you've seen I've emphasized again, I've said the present values. There are these expected cash flows from the project. They are in the future. Listen carefully. If you invested your money right now in year 0, 50,000, then after 1 year, you will receive $18,000. In the second year, you have $25,000. In the third year, you have 20,000 and 10,000 in the fourth year. You get that, right? So now these are just projections, the expected cash flows, what you're expecting to receive from this investment. Listen carefully. So it therefore entails that these cash flows that you have, the expected cash flows, are in the future, right? Because these are basically the projected flows. Since they're in the future and your initial outlay is in the present, then you will have to discount these future cash flows, right? For example, cash flow number 1 in year 1, you have to discount it, bring it to the present, 1 plus R. The discount rate is given in the question, or the cost of capital, if you may like. Discount it at the cost of capital plus cash flow 2, which is in the future, right? Discount it. To discount is just to say 1 plus R to the power n, right? So in this case, if it is in the second year, this will be the power 2 plus you discount again in the third year, divide by 1 plus R to the third. You go on discounting up to until to the cash flow n divided by 1 plus R to the degree n. When you have all this, if you do this computation, this shall give you the present value. You're listening? That will be the total value of the present values. And then from this sum, you will deduct the initial outlay of the investment, in our case, the 50,000. And then you look at the NPV that you find, whether it's positive or it's negative. Is that clear? Okay. Now you are understanding. So there are many ways of actually doing it, but I'll go the tabular method where you tabulate, you put a table, right? So you can put here, listen carefully, the year, then there is cash flow. We are answering the question now. The cash flow, CF for the cash flow, what you get from the investment. There will be the discount rate at the cost of capital for part A. We are doing part A. It is discounted at 15%, right? Discounted at 15%. Then you will have the present values on the other side. How do you find the net present value? Part A of the question. Let's start. You have the cash flows. The years are 0, 1, 2, year 3, and year 4, yeah? Yes, sir. Then the cash flows are given in year 0 is negative 50,000. Can you see that? In the first year, you have 18,000. In the second year, you have 25,000. You have 20,000 in the third year and 10,000 in the fourth year. Okay? Tell me we are good up to here. Now, these cash flows are in the future. This is what I've said. We want to bring them back to the present. Is there any question up to here? Please say you have a question if you do have. Now, listen carefully. I told you that to discount this cash flow, these cash flows, it is cash flow divided by 1 plus R to the power n, isn't it? That's what I said. Cash flow. So you know that from your knowledge of mathematics, this is same as cash flow times 1 over 1 plus R, right? To the power n. Do you agree that this is equal to that one? Because, look, it's as good as you put over 1 here. Again, you say C times 1, it will still be C over 1 plus R to the power n, which is the same thing again. So I'm trying to show you that you could still separate and calculate for this part, since you already have the C's, these are your C's, the cash flows. Calculate for this part that I've circled. We call it the discounting factor. Is that clear? It is called the discounting factor. Okay? That's the discounting factor. So let's find the discounting factor. How is it done? You just say 1 divided by 1 plus R to the degree n. Okay, let's move a bit faster. I want you to follow nicely. So we are going to say 1 divided by 1 plus r to the degree n. So you shall say 1 divided by 1 plus, our r is 15%, the cost of capital, which is 0.15, yeah? Someone is asking, how do you get to 0.15? You just say 15 divided by 100. It shall be 1 plus 0.15, right? And then you add the two, 1 plus, 0.15, that should be 1.15, yeah? That will give you 1.15. Okay, so 1.15 to the power n. Now, n is the number of year or the n number. In the first year, you have year 0, right? Like in the first line, we have year 0. So what do you get when you calculate? Just to say 1 divided by, 1.15 to the power 0. What do you find? Obviously, you should be able to find 1.000. Is that clear? Is it what you find? Hello?
Yes, it has to be 1 because the 1.15 to the power 0 gives us a 1. So
Yeah.
if we say 1, we've got down, we divide it into the 1 up, it gives us 1.
Okay. All right. So then in the first year, you raise this to the degree 1, to the power 1 in short. Instead of power 0 now in first year, you are raising this to the power 1. And what do you have? This is as good as 1 divided by 1.15. What do you get at the discount rate? This one, you call it the discount factor, all right? That's a discount factor. What's the discounting? What is the discounting factor?
It gives
Hello?
0.8695.
Sorry?
Okay, it
0.
gives us 0.8695652217. It ends on 7.
Okay. Is everyone finding the same? All those with calculators, please confirm the figures. You don't want to make a mistake now, because if you make this mistake, everybody will follow the recording. So you have to do the right thing. Anyone to confirm? Hello? Agatha, you said you have a calculator. Are you punching your calculator or you have stopped? Hello? Colleagues, are we even together, or people have just logged in, they are not there? I've left their gadgets logged in.
For me, I'm
Hello?
here, sir.
Yes,
Hello.
I am finding out. What do you find? What do you find when you calculate? Okay, we can go to the second year and raise this now to the power 2. All right, if it's a second year, you raise that to the power 2. What do you find? Should be 0. What? We need to do this quickly. The question is still huge. We are still going far, right?
Just give me a few seconds, sir. it gives us 0.7561436667. Can I
Okay.
come again?
So come, oh, what did you say? 0 point what?
0.756
1.
1436667.
0.7561. Just 4 decimal places, I think are okay. Then you can raise it to the power 3. That is in the third year now. Okay? You have to be trying out these things. That's when you'll be understanding what you're doing. Eh? Yeah. What did you find? Zero 0.6575. Is it what you get as well? Hello?
Hello, sir. I'm just trying to confirm. So yeah.
Yeah, let's teach ourselves to punch calculators quickly. You know, in an exam, math, many people don't finish because they are quite slow in punching their calculators. You get what I mean? Let's teach ourselves to be fast.
Yeah. Yes, it gives us 0.6575.
All right. Okay, so in the fourth year, you should be able to get 0.5718. Okay. Now let's find the present values quickly. To find the present values, what you're doing is you just multiply, you know, this cash flow times this discounting factor that you have found. All right, this is what you're doing. So say negative 50,000 times 1, this side would give us negative 50,000, is it? Then 18,000 times 0.8696, what do you find? If many people were calculating, we could have moved fast. And I expected many people to be calculating. So that we just do this within 2, 3, 4, 5 minutes, we are done. And we get another question. Seems people 6. What do you find?
times. Okay, sir. Did you say we are multiplying?
You are multiplying the discount rate times the cash flow.
Okay, so that's 50,000 by 0.8696.
This cash flow, the cash flow, which is 18,000 now. 18,000 times the corresponding cash flow in year 1. 18,000 times 0.8696.
Okay.
So, hello, sir. It's giving us 15,652.8.
65.
15,652.8. Yes.
All right. Let's go to the what's this? The second year. Just multiply 25,000 times the corresponding discount.
It's giving us 18,902.5.
903 then.
Yes.
Everybody is finding the same?
Yes.
Okay, you can go to the third year. 20,000 times 0.6575.
13,150.
You can go to the fourth year.
Giving us 5,718. 5,718.
Okay. So now to find the net present value, you simply add all these which are positive. This is what I meant by consolidating the present values. Okay. Add them, then you deduct 50,000. What is your NPV? Very easy, eh?
Yeah.
So before you go further, sorry to take you back. I get how you're getting how you're multiplying the CF and the discount to get the PV. But I'm a bit behind on how you are calculating the discount.
Oh, okay. I said the discount is found by saying 1 divided by 1 plus R to the power n. The R in our question, the cost of capital is 15%. So you say 1 divided by 1 plus 15%, which is 0.15, right? Yeah, that's 15%, 0.15. When you add that, it should give us 1.1.15, right? To the power n. And n is the year number. So in year 0, like in that year 0, you just put this to the power 0. You punch your calculator, it will give you 1.00. Then to the power 1, in year 1, you just say to the power 1, the denominator to the power 1. Nothing much. You say 1 divided by 1.15 to the power 0. You'll be changing to the power 0. You get that to the power 1. That will be for year 1. To the power 2. That will be for year 2. To the power 3 for year 3 and 4 like that. You got it?
Yes, sir. Thank you.
You're welcome. So can you add all these and tell us the present value? Add, then you deduct 50,000.
It's giving 3,424. If someone should confirm as well.
3,424.
3,424. 3,424. Everyone finding the same?
Yes.
Now listen carefully. This is the positive NPV that you have found, which means according to this, you accept the project. Remember the decision rule that I gave. You find a positive NPV, it means that you're receiving more from the project than what you injected. Is that right?
Yes.
You got it? Is there any question? Someone has a question? Okay. If you have understood part A, then part B will be the easiest. B is saying now we want to do the same, but we use 20% the cost of capital. So we just change here on the discounting rate and the present values will change. Right. These are the only things that will change. We are on B now. B of the question. Just a minute. All right. We proceed. Let's proceed now on part B, and we are using 20%. Okay. And the thing is that you change the discount rate, right? It will be 1 divided by 1 plus R to the power n. Same formula. Now the R is 20%, which will give you 1 plus 1, divided by 1 plus 0.20. That's 20%, right? And that will give you 1.10, 1.20. To the power, in the first year, you say to the power 0. 1 divided by 1.20 to the power 0. This should give you 1.0000. In the first year, you raise this to the first degree. What do you find? What do you find?
That's 0.8, and then there's a recurring 3.
Okay.
Yes.
What about in the second year? You raise this to the power 2. We can be a bit quicker and faster.
Gives us 0.69, and then there's a recurring 4.
Is that the case with everybody?
Yes.
Yeah, in the third year.
Gives 0.578. Then
0.578.
7. Yes.
Like this?
0.57870. Then there's a 3703. So
87. Right?
yes.
In the fourth year, you raise this to the power 4.
0.8223 rounded off.
Sorry?
0.82. Oh, sorry, 0.48225.
482.
2, 5.
Another 2.
Another
2.
2. Yes.
Then 5.
Mm.
Okay. We can find the present values now. Negative 50,000, right?
Yes.
What about the first year? I guess you got the present value that we found the previous line. You have written it somewhere. We'll be stuck. We need it for C, for IRR. What did you find?
Found 14,999.4.
14,999. Okay. Everybody finding the same?
Yes.
We go to the second year. What do you get in this from the second year?
17,360.
360. In the third year,
Is it 11,574?
11,574. What about in the fourth year?
$4,823.
4,823.
23.
Then you can add these and deduct the initial outlay, the 50,000, to find the net present value. What do you find?
I found negative 1244.
1244. Everybody finding the same? Yeah?
Yes. Yes, we're
Yeah.
getting them.
So B gives us a negative NPV. Do you remember the NPV that you found for A? It was positive. What was the number? The amount we need it for C.
Was it 3,425?
Sorry?
3,425.
325, like this, not 24.
It
Or
was
something.
24.
It was 24.
I have something like 3,424.
24.
Yes, because you had written it at the bottom of the table,
Oh, yeah.
said NPV equals 3,424.
Okay. That's our B. Let's go to C. So now, to find IRR, listen, for C now, we're on question C. IRR is given as follow: A, capital A, plus positive NPV over positive NPV plus negative NPV, right? All this multiplied by higher rates minus lower rates. Then you understand what I mean, don't worry. Okay. Then percent. Is that clear?
All right.
Any questions? There are no questions. Now you want to
No.
know what, I guess the class is being recorded. Okay. I don't have time to repeat this. All right, let's go. So what is our A, the capital A? What's our A? Let's start defining. Our A is the lower rate. The lower rate that gives you a positive NPV. Is that clear? Then B is the higher rate. You're following, right? The higher rate that gives you a negative NPV. You get what I mean, eh? Then P, it is the positive NPV. Okay? And then N is the negative NPV. Did you get that one? So in short, it shows that you need 2 NPVs for you to find the internal rate of return. 2 NPVs, okay? 2 of them. The other one should be positive. The other one should be what? Negative. Then you can compute in this formula and then you are fine. Is that clear? So don't memorize no P, N, what. When you go in other literature, you may find different letters. What is more important is just to define, you know, the way how you're using these notations here. You can tell us, oh, A means this, okay? B means this. Don't point fingers to the teacher when you go in another book, you find they are using other letters. You start saying, no, the sir was lying to us. I'm saying they can use any letters. What is more important? These are just arbitrary letters. You could define them. Tell us what you mean. Which one is the lower rate? Which one is the higher rate? That is what is important. You've gotten it? Okay.
Yes.
You have understood. So what is the higher rate? The lower rate is 15%, isn't it? The higher rate, we found 20%. The positive NPV was 34.24, yeah? And the negative
Yes.
NPV was 1244, isn't it? Negative. Now we need to put the negative one. Please get the message. It is treated as an absolute value. It is always treated as an absolute value. So always positive, in other words, right? Always treated as a positive value. Okay, let's proceed then. We just have to start substituting. What is our A? Let's start substituting you. What's our A? Our A is 15, right? 15 plus, open the bracket. The positive NPV is 3424 divided by 3424 plus what is the negative NPV? It is 1244.
44, yes.
Minus beta, the highest B is 20 minus 15, like that. You got it? Right.
Yes.
So you can go ahead and work out this. What do you find in the denominator when you add 3424 plus 122? What do you find?
Yes. Gives us 1,302. 1,302.
No, it's not possible. 3,424 plus 1,244.
Oh,
You
sorry.
can't get
I thought
1,000.
it was a 34 and then 24 separate. Okay. 3,
Add this, the
4.
denominator add.
It's giving
Yes.
us 4,668.
68.
Mm.
Okay. 3, 4, 24 times 5, right? 20 minus 15 is 5. So let's work out the parentheses. What is 3424 divided by 4668? Zero point what?
733504712.
Okay, times 5. Multiply that by 5. Multiply this part. What does it give you?
It's given 3.66752365.
When you add 15, that should give you 18 something, isn't it? That should be 18.6675, isn't it?
Yes.
That's your IRR. 18.667. Rounded up to 19%. Right. If you round it off, you can round it off up to some 19%. That's the rate, the IRR. Is that clear? That is clear, isn't it? We'll go to D. D is easy. Recommend on financial grounds alone whether this project should go ahead. You just say, using IRR approach, you compare the IRR that you found with the expected rate of return. In our question is 17%, right? So the decision rule is, if the IRR is greater than our expected return, all right, then you accept the project. You get it, right? If IRR is less than the expected return, then you have to reject the project. Okay. You've gotten that one, yeah? Hey, did you get that
Yeah.
one?
Yes,
Yes.
And then from there, you can go ahead and look at, of course, if IRR is equal to R, it means we're breaking even. just like to the NPV. So using the NPV approach, we found that the NPV was positive at 15%, right? We accepted the project. Now using IRR, should we accept this project? What do you think? Your IRR is 18.6 something percent.
which
And
is
your
19.
target rate is 7. What is your conclusion on D?
I think we should accept the project because
Yeah, because the IRR I see is greater.
it's greater than the rate.
Yeah, IRR is greater than the expected rate of return. Is that clear? That's what you put on D.